مساء الخير. بروفيسور علي.
اهلا اهلا.
Good afternoon, everyone. Thank you so much for holding. This is Mohammed Al-Mughazi. Welcome all to this. Frankly speaking, we've had several webinars in the past, but this one I have personally special interest in for obvious reason, for the sake of the topic, but most importantly, because we have a very distinguished guest today, Professor Rahim. And frankly speaking, Professor Rahim, please forgive my ignorance. So I did have a call from one of the leaders in the telecom industry in Egypt after sending the webinar link. And he just simply asked me, how did you get Professor Rahim on board? And I told him, he's a nice guy. I've met him in Connecting the Skies event in Riyadh, and I've just asked him, and he said yes. And then he started telling me that Professor Rahim is one of the main contributor to the mobile technology around its previous generations, 2G, 3G, 4G, 5G, 6G, you name it. So Professor Rahim, again, a very sincere welcome to you from Cairo. And again, forgive my ignorance. And if I may, I want to start by asking you, if you allow me, please, a simple question, and not to make you old, but I know you've witnessed the development of 2G, 3G, 4G, and 5G, and you yourself was part of that development. Everybody is talking now about 6G. What is different in the case of 6G when it comes to NTN? How is the integration is possible, considering that, at least to my knowledge, when we are talking about mobile generation, we're talking about 10 years between generation, which is not the case between the different satellite generations.
All right, do you want me to start or?
Yes, please, go ahead.
Okay, no, thank you very much. And thanks very much for all the nice and kind words you gave, Mohammed. It was great to see you in Riyadh, of course. And I'm really happy to be part of this distinguished panel to have a discussion. Yes, I've been involved in first generation of satellite PCN. If you remember, Iridium, Globostar, ACES, ICO, they were called the first generation satellite PCN. Personal communication networks, satellite personal communication networks, and we have learned a lot of lessons from that, which I will share with you. And on the terrestrial side, yes, 2G, 3G, 4G, 5G, and now working on 5G Advanced and 6G, together with the second generation of the satellite mobile personal communication networks. So you asked, what is the difference between 6G and 5G, for example, and previous generation system? There are many aspects. 6G is more about convergence. And it is not only my academic view, but in 6G Innovation Center at the University of Surrey in UK, we discussed about 4 years ago, more than 4 years ago, with our industry partners, which is like operators, manufacturers in UK and global. So what should be the network be in 2030? Whether we want to call it 6G, you want to, whatever G you want to call it. And unanimously, everybody said it has to be ubiquitous coverage. So we need to solve the problem of the coverage, but not coverage for only voice or short message services, but quality coverage for data as well and video. So that was one aspect. The second aspect is convergence between IT and telecom. So everything is going to be softwareized as much as possible and reconfigurable, adaptable, and etc. The third thing is it is integration between sensing and communication. So the sensing can help the communication, and communication can help the sensing. Another aspect was the intelligence. We want the network to be as intelligent as possible because the network becomes so complex and complicated. Probably it is beyond human operators' capability. And at the same time, AI and machine learning techniques have advanced so much that we probably can let the AI ML to automatically optimize the network and reconfigure the network and different parts of the network more intelligently. Another area that we thought that 6G would need compared to 5G, for example, is a time synchronization. And it is in ITU 2030, it is already mentioned in that, which was published last year. Time synchronization and edge computing is important. For example, applications and use cases that integrates the physical world with the digital world. Some people refer to it like a digital twin. Some people refer to it as cyber-physical interactivity. So these are the main distinguishing features of the 6G. Going back to the first requirements, which was quality coverage, we realized that with one technology, we cannot really provide cost effectively and energy efficiently ubiquitous coverage for indoor, outdoor, and remote areas in the sea, in the air, whatever, all this operating environment. So it has to be a network of networks. So the system architecture for 6G would be a three-dimensional network, which is space, satellite, UAV, HAPS, and terrestrial system, to work with each other seamlessly and especially from the user's point of view. So user can access its services and its coverage irrespective of whether it's connected to satellite or HAPS, UAV, or terrestrial system. So these are the main distinguishing features. And I mentioned that we learned a lot of lessons from first generation of satellite PCN. And that was the main lesson. Satellite and terrestrial should not compete with each other from the market. None of them going to be the winner. So it is better for them to collaborate and cooperate, interwork, and come up with one unified three-dimensional networks that complement each other in areas that satellite is more cost-effective and is available, and this in the areas that user happen to be the terrestrial means or terrestrial networks will provide that same services. So I believe that this is the biggest lessons that learned, and I'll be more than happy to elaborate on any of these issues that I mentioned during this meeting.
Thank you so much, Professor Rahim. This is very enlightening. I will come back to you with second and last question after the current panelist. And my second panelist is Mr. Kezias Mwale. Mr. Kezias Mwale is very well known to the 54 African countries when it comes to spectrum management. Probably if you're dealing with the spectrum, you may ask for his help. During the past years, he's the dynamo of the African Telecommunication Union. And under the leadership of Mr. John Omo, I think the ATU has turned it into a very developed entity when it comes to spectrum management. So, Mr. Mwale, I know you've been in the past working with the regulator of Zambia and now with the ATU. What do you think the needs of the developing countries when it comes to the new LEO system? And I'm sure you've heard the news recently of some African countries ceasing the operation of some LEO companies. How do you think we should deal with that as Africa or as a developing countries?
So, first of all, it is an exceptional honor for me, my brother and friend, Dr. Mugazi, that you personally invited me. Really an honor for me. As I begin, I wish to just recognize the leadership from the GTPRN, and more so to recognize the professors in our midst. Now, what you ask is a very important question. What do we do with the emerging technologies? In my view and in our view, what we need to do is something that is quite obvious, but sometimes we overlook, is to appreciate the opportunities, the emerging technologies. In fact, you cite the LEOs as an example, to appreciate their capabilities. In our case, for example, and because much of our region is developing region, up to today, unfortunately, and if you look at the recent released numbers by the ITU in terms of internet usage, that figure is only about 43%. So internet usage, meaningful usage, is standing at only 43%. It means that we still have a majority of our people still offline. Even when they have some form of connection, that connection is still not meaningful. So as you can appreciate, Dr. Mugazi and senior people on the call, it means that we have to, and I've admitted that sometimes we do not sit down to fully assimilate and appreciate the capabilities of the new system in order to collectively develop interventions that will maximize the capabilities, the benefits from this new emerging system. And also, what we clearly, our challenge is clearly speed. Rather than acting as an enabler, we seem, and I'm being extremely careful here with the words, we seem to lag behind in terms of creating the enabling environment. You've cited the LEO, for example, and clearly, and you may say this is an indictment on the part of the ATU that yes, we developed the emerging technologies, the implementation of the emerging technologies recommendation 005, but on the ground, so we have what you would say a model of how we can benefit to create this harmonized framework. But what we have on the ground seems to be different. Again, I'm being extremely careful with my words here. What we have on the ground seems to be different. Why? Because if you read the big news on, for example, let me not name companies by name, on the leading LEO system operators, the news that's coming from Africa is not coherent. You have one country licensing the LEO operator in one fashion, and another licensing the operator in another fashion. And west, you have another country or group of countries who do not even have a local framework on how to license, or rather authorize the services of this level. So if the regulation is missing or not yet there, how? I mean, for me, the logic says that there's just no way to begin to benefit, to begin to leverage the offerings, the new offerings of the new emerging technology. So I can go on and on, I mean, Dr. Mogazi, but I think we should, it's a pity up to today we seem to, especially at a ground level, maybe at an African level, we could forgive ourselves because yes, we have, for example, in this particular case and in the specific example of the LEO systems, we have recommendation 005, which sort of is very clear on how to license, recommending member states, African countries, who today, by the way, are almost all African countries, because the membership of the ATU today stands at 52 member states who have willingly, voluntarily chosen to associate with the ATU. And that number is, even when your counting is 54 African countries, or even when your counting is 55 African countries, 52 out of 54, 52 out of 55 is almost 100%, Dr. Mogazi. So we seem to have done well at a global, at a continental level, but certainly the news that we are getting from the ground say that enabling policy is lagging behind. Let me stop here, otherwise this is something I could go on and on, unless you permit me to go on and on. But again, to thank you so much for this opportunity. Thank you.
Thank you so much, Mr. Kezias, and I can see why you are careful with your words, giving the leadership from Africa that are attending this meeting. I can see some names in the list, but let's move into the industry, to the distinguished Miss Fatima Karim. And Miss Fatima is the head of ASMG Spectrum at the GSA, and she's also a director of a spectrum policy at Huawei, and she's one of the few, frankly speaking, from the industry that I personally seek their unbiased advice. And Fatima, I know you've been deeply involved in the development of mobile technologies within the 3GPP, at least from a European perspective, and you've seen the development of mobile technologies. How do you see the role of satellite component is different from its first introduction? If I remember well, and please correct me, in 3GPP release 15 till the forthcoming release 19. What's going to change? What are the changes?
Thank you, Mr. Mogazi, and it's really an honor and privilege for me to be among this panel of highly known people. So Yes, I have. I had the privilege to be an active member of 3GPP for many years, over decades, where I contributed personally to shape standards for LTE, LTE Advanced, 5G, and so on. And we see the generations, passing by. And I agree with Professor Rahim. This ubiquitous coverage is part of the picture for 6G, the way it was also part of the picture for 5G. Now, if we look to the standard, how it is built, the terrestrial technology, whether 4G or 5G and also 6G, has no limitation technically in terms of how it could serve coverage to everywhere, basically to populations. So it is not a technology limitation. The real issue of this usage gap that has been highlighted by Mr. Kezias is not technical, is not technological, it is economical. And this is why we need to analyze it in order to understand how these technologies can complement each other and how they can better or complement each other. So Mr. Kezias has highlighted that we have only 43% of the population which is using or has access to the internet. Now, if we look to the other side, we have numbers telling us that in terms of population coverage, like over 90% of the world population, if we include China, and if we don't include China, it's something around 85% of the world population is covered by mobile terrestrial networks. So majority of world population is covered by mobile terrestrial networks. However, only 43% of them, or something around, has access to the internet. So what is the problem there? The problem is a problem of affordability, economical affordability, not a problem of this population coverage by some mobile terrestrial technology that would allow them to access to the internet. And that issue, so this difference between the population coverage and the usage coverage is to be understood under that explanation. There is a problem of affordability, and there is that needs to be resolved, and there is a problem also that contribute to that of illiteracy, okay, in some of the regions, to which the solution cannot come from the technology, cannot come from whether this population is served by satellite or served by terrestrial networks. It doesn't resolve that issue. That issue should be resolved by other policies. Now, in terms of affordability, while I think there is a number of policies that can help improve the affordability of mobile terrestrial connectivity in areas where it is the issue, I think we need also to think about the affordability of this satellite NTN connectivity in order to have some effective way of complementing the existing terrestrial coverage. And coming back to your question, Dr. Moghazi, regarding the standard, the 3GPP standard since release 17 includes and technology 3GPP NTN standard that serves MSS direct-to-device communication, or NTN direct-to-device communication in S and L bands. So the standard for such technology is available under the 5G standard. It's there and it's defined, and basically if we are looking to the future, what I would see is that components for that how to say, complementarity is already in the standard today and can be improved, obviously, in the future. And maybe I'll pause here in order to leave the door for some more questions.
Thank you so much, Fatima. I'm trying to tease you here with the questions and challenge you. I hope I will be successful in my second round, but let's move to also a big part of the satellite industry, Mr. Amr Ashour. And Mr. Ashour has worked for the regulator in Egypt and in Oman, and he was also part of Arabsat. And then he has moved to OneWeb, which is being acquired by Eutelsat. And my first question to you, Amr, and I hope you have an answer for this, because many of us has witnessed the changes within the satellite industry. So we've seen the rise of OneWeb and then bankruptcy of OneWeb. OneWeb got a fund from SoftBank and Bharat Group, and finally the merge with Eutelsat. And I've seen a similar pattern within the satellite industry. CES and Intelsat, Viasat and Inmarsat, EchoStar and Dish. So, Amr, what's going on? Why these mergers and the acquisition within the satellite industry? Why now, and what does it mean?
Thank you, Dr. Moghazi, and thanks for the kind invitation for joining this panel. It is actually truly a pleasure to being here and actually to share and participate with my panelists and also the colleagues here joining the call. So I think you touched on a very important point, Dr. Moghazi, the situation of the acquisition and merging between technologies. And I think this confirms the idea mentioned by Dr. Rahim in the beginning about the convergence and about also the subject of this today meeting. So the main point that you highlighted here is implemented, as you can see. So by having this type of sort of acquisitions or mergers between the different operators, so we are seeing, for example, I will speak here on my part mainly. When you see Eutelsat actually started in the market 40 years ago with the GSO system, providing a lot of innovative products to the market. And then when there was a decision to further innovate and to employ new technologies, they started to apply vertical integration by including a portfolio of an additional network that will serve another purposes. So it will not be, we can simply say the answer to your question here, it is merely a complementary part between technologies. We believe that both there is not a single technology or single network can attain or meet the requirements of ubiquity, of quality coverage, which I like this term very much, the quality coverage and ubiquity. I believe that Dr. Rahim touched on a very important point here about this part. And therefore, using different types of networks in order to ensure the affordability of the services, the ubiquity, the quality coverage is something very important. And also highlighting here the point mentioned by Mr. Kezias. Actually, he's a great mentor in this region, and I think he touched on a very important point regarding the access and the ATO efforts in having the harmonized framework for the licensing, which is still a very huge barrier for the satellite communications in the region, in which, of course, there are countries that use the ATO recommendations and they develop it further and evolve it further. And some other countries are still not working on that. But we can say by the end of the day that there is also some continental efforts on the regional groups level happening today in order to recognize the use of these networks, merging it with the network capabilities and the different ways of offering things, either in the GSO or in the non-GSO, or even in the terrestrial, creating a complete portfolio for the user to have by the end of the day, the affordability aimed and highlighted by Mrs. Fatima. Despite the policies and something very crucial as well. So we need to have a policy that understand and recognize this sort of integration and complementation between the different networks to offer the services by the end of the day. So I would believe actually that the most difficult part we are facing in the industry when it comes to this part would be mainly the policy part and the licensing part, which is a very crucial and essential element for us to deliver the services on the main or the objectives that we need to do. Of course, each country have its own sovereign rights to control and to guide how this works. But we have seen that some of regulations may actually do not allow this implementations. And to satisfy this, I think the policy is a key factor in doing that. By having these both elements in hands, we can have by the end of the day the affordability and attain or reach the ubiquity and the quality coverage by the networks. So I hope this addresses your question, Dr. Mwale.
Thank you, Amr. I promise you to tease you more in my second question, but let's move to our last but not least speaker today, Dr. Abdulhadi Aboulmal. He was the head of spectrum and the standardization at Eutelsat Group for 15 years. And then he was VP of eSpace. And then he decided to focus on his endeavor in having something new. His recent company, MEA-COMM, provides some innovative solutions, and he's the CEO and founder of that company. I'm aware that Dr. Abdulhadi is now at the airport, but appreciate his time. And I want to ask you, Dr. Abdulhadi, given that you were one of the proponents of Agenda Item 1.13 of the coming World Radio Conference of 27 on NTN, what is the expected results of that agenda item? And frankly speaking, I'm curious. The US has recently allowed some regulations for Starlink. So do we need the output of Agenda Item 1.13, or we can follow the US or develop some national regulations?
Thank you very much, Dr. Mwale. I hope you can hear me.
Yes, very well.
Dr. Mwale, yes, thank you very much, and it's a pleasure to join this esteemed panelists, my colleagues, Amr, Fatima, Kezias, and Dr. Rahim. I think the discussion happened in ITUR WRC 23 was an example of what all my colleagues here mentioned, going all the way from the challenges that we have seen across coverage, and that's why we came in 6G with a clear vision saying we need to have a ubiquitous coverage, and looking to the affordability and how we can make sure that whatever solution we're trying to use to connect the unconnected is affordable. And I think even Fatima addressed this point. Kezias talked about the regulation, and I think I fully agree. And maybe there's an opportunity where we can utilize 113 with the underlying resolution 253 calling for the studies not only on spectrum coexistence, or I would say coexistence between satellite and terrestrial networks, but even looking for operational and regulatory aspects as well. I think it's a good forum to look at multiple aspects that will help our countries. From MEA-COMM perspective, when I established MEA-COMM, the vision was how to enable the industries, how to make use of the technology in a very effective way. We looked at it from Industry 4.0, from the Industrial Revolution 4.0, and how can 5G, whether they are on the earth or even in the air or even in the space, can address different requirements of Industry 4.0. But going back to the main concept, I think Ove is there as well. We are listening to his point.
You're talking about the ITU, so he should intervene somehow.
Yeah, that's why. Yeah. So it's a pleasure also to hear his voice as well. So going back actually to the discussion on WRC 23, I think it was a very nice example where we are converging and where we are, I would say, diverging somehow. But not saying diverging, I would agree with Dr. Rahim, we need to complement each other. The initiative in WRC 23 is supported by a number of regional groups even, and I got the pleasure and the honor to present the group position on that agenda. I would think the whole dimension proposal was about harmonized ecosystems, right? So we have different type of initiative already running on the ground or even in the space right now. And having these silos, I would say, is not healthy for many developing countries. That's right. Having a bigger ecosystem or a bigger framework that help developing countries, especially MEA region, and that's why we called it MEA-COMM actually, but especially in MEA region, you know, where there are growing interest in the space sector, especially in the LEO, by the way, definitely GEO. We have multiple projects running in the space right now. But when we come to the LEO, with the understanding that 80% of time your satellite is running over the sea, then you have to think about it from what value you can create, whether for the sea or for the land, right? The proposal was coming to say we need to complement the land ecosystem, especially with maritime IMT ecosystem, IMT systems, where we can use the IMT across different layers. So, and in challenge here, how the coexistence between the IMT system and the IMT space component will and we understand the concern at the time from many terrestrial operators saying, okay, what will be the impact? Do we expect somebody coming from the space asking for license even in the our territory of our country in the same band we're using? I do not think that was the intention at all. We speak about spectrum mostly in many countries, license not on geographical area basis, but license on the national level. That's right. If we think about from that perspective, then the satellite opportunity discussion and then in the agenda item 1.13 was there to complement the existing ecosystem, to complement the existing coverage of the terrestrial operator with a satellite component that can connect the unconnected, address the remote areas.
It seems that Dr. Abdulhadi has been disconnected, but I think he was almost about to finish his intervention.
Yeah, it's
Doctor.
So, ecosystem. Well, you
Dr. Abdulhadi, your voice is being cut. Perhaps you can close the video if you want to continue.
Yeah. Just to conclude, I would say for people to support governments to set their.
So it seems that Dr. Abdulhadi was cut again. I'm not sure he's connected through NTN solution, but I think we've spent 40 minutes now. Don't want to take more of your time. So perhaps we can take a final questions or a final question from me to Professor Rahim. I don't want to miss the chance, Professor, so please forgive me. And then we can take a couple of questions from the audience. So Professor Rahim, I've noticed you're one of the few in the academia that have specialized in the mobile and satellite technologies. And again, not to make you old, but I think you noted that the rise of the satellite industry, this time of the late technologies, the Starlink, Amazon, and OneWeb, and so on, is the second rise. We did have a similar movement, perhaps at the 90s, similar dream of having this satellite broadband and ubiquitous connectivity everywhere. I'm not sure if you're aware of the US company Teledesic, which was bankrupted at that time. So in terms of the satellite technologies, what is different this time? Why the LEO and the dream of having internet connectivity from the sky it could be possible this time? Professor Rahim, are you there? You are muted.
Yep. No, Thanks, Mohammed. And thanks very much. I think it's a very relevant and important question that you ask, especially for people who think that satellite is expensive and is not affordable in order to connect the unconnected with possibly less income countries, for example. In the first generation of satellite PCN, when we were talking about like Iridium, Globalstar, and Teledesic, and etc., the economy of the space has fundamentally changed for over the last 30 years. And thanks to Elon Musk and Starlink, I think that brought that fact and reality to many people's attention. They said, look, this is from the cost, from the launching, from the spacecraft, from the operation, everything has come down so much. And I believe that the reason I support unification between space and terrestrial, if we don't do this properly, again, we are going to face the same problem of the satellite or NTN will be too expensive. I think it is the combination of the two that makes it more cost effective. And another factor is like Iridium and Starlink and etc. The price could go down if they are not proprietary technical solution. If it is a global standard and there's a common technology between a space and terrestrial system, the economy of a scale will reduce the total cost of the system, and therefore the users will benefit more. So all of these factors, when you put it together, you become more optimistic about role of satellite in 6G and or even be in 5G advance, and make it more affordable and cost effective for everybody. At the moment, most of the system that you said, the second wave of the system like Starlink and etc., these are not a mobile broadband system. They are fixed broadband system. Of course, like I think our colleague Ashour can verify this. For example, OneWeb has a different business model, and that is more business to business sort of model. But what we think that would be the game changer is business to B2C, customer to customer, consumer. And it is, I believe, that direct to vehicles and direct to handheld is a game changer for the economy of the space and terrestrial system.
Thank you so much, Professor Rahim. And again, it's a pleasure and honor having you here. I would like to personally take this chance not only to thank you, but to continue the dialogue with you when you have the time, perhaps if you visit Cairo in the near future, or if I'm nearby University of Surrey. Thank you so much. And now, as we are coming to the end of our session, I will give the floor the chance to ask our esteemed participant. And frankly speaking, I did have a special request before the meeting from Professor Tariq Atiyah. He's one of Professor Rahim's student, and he's one of the senior representative and leadership of telecommunication regulation in Egypt, and he wants to take this chance to say hi and ask you a question, if it's possible. Professor Tariq, are you online?
Thank you, Dr. Mohammed, for giving me this chance to share the enjoyable discussion of the panelists. And I am very happy today to hear this session from Professor Rahim Tafazolli, who is one of the most famous researcher in the field of research and development of mobile network for 5G and 6G innovation. And the first time I had the honor of meeting him was in at Surrey Space Center with Professor Peter Sweeney, Sweeney and Professor Martin Sweeting. Thank you very much. For my questions, I have two questions to Professor Rahim. The first one, has 5G technology practically achieved the requirement of the latency of 1 millisecond delay? This is the first question. The second question, can 6G technology, which integrates with the terrestrial wireless network and satellite network, achieve the requirement of latency 1 millisecond delay? Thank you very much.
Okay, thank you very much, Tarek. It's nice to talk to you after so many years. I'm glad that you are doing well and you're a professor now. Excellent. So this is a good question. I think I've given many seminars about latency in 5G. First of all, it is very important to know not every application requires low latency. Not every. There is a very few application that requires low latency. So that's one thing. The second thing important about latency, it is not about the magnitude of the delay, like 10 millisecond or 1 millisecond. It is more about reliability of that latency, in a sense that for some application, we want 99%, say 1 millisecond, 99% of the time we want, say 10 millisecond, or whatever it is. That is more important than actual magnitude of the latency itself. The jitter and reliability of the latency is important. So if we have that reliability, we can control cars, we can control robots, we can control I had another thing in my mind, vehicles and etc. So when it comes to satellite, okay, because of delay, because of even is very low Earth orbit, majority of the applications that is controlled by terrestrial, like with indoor, for like robotics or vehicles, outdoor and etc., you don't need to control it using satellite. We tested with the VLEO the delay, and we were interested not only in the magnitude of the delay or latency, which was the system that we tested was about 14 milliseconds, but the jitter and the variation in the delay was small enough, I can't remember the exact number, to control machines or robots or whatever it is. So please bear in mind, not every single application needs to be done with a low latency part of the 5G. And answering your question, 1 millisecond low latency in a standard, in ultra reliable low latency communication, it is, the technology is there. We tested low latency because we have a test bed here, and we, on one way, like uplink was 1 millisecond, on the downlink after was 1 millisecond on the radio, and on the edge computing was about 2 milliseconds. So there's 4 millisecond round trip delay. And more important one, was 99.9999% of the time, I can't remember, 5 nines or 6 nines, it was 4 milliseconds. And that is more important than actual magnitude of the delay itself. I hope I answered your question.
Thank you so much, Professor Rahim. It's jitter and latency. I got it. So
Okay, good.
thank you so much. Perhaps we can take a last question from the floor. Please raise your hand. If not, thank you so much for this enjoyable webinar. Thank you so much, Professor Rahim, Mr. Kezias Mwale, Ms. Fatima Karim, Mr. Amr Ashour, and Dr. Abdulhadi Aboulmal. Thank you so much. The recording of this meeting will be published along the last webinars in our forthcoming issue to be published in January. Please make sure to follow our community. We are a small community, but working for the benefit of telecom policy research around the globe, and we're looking forward for your participation in our next webinar on artificial intelligence next week. Thank you so much, and have a great one. Bye-bye. Assalamu alaikum.
Thank you, Doctor. Bye-bye.
Thank you.